Hello and welcome to 11y cubed. I'm Mr. Chowdhury. Today we're going to be looking at mathematical similarity. In particular, what is mathematical similarity? Before we do that, we need to make sure that we have a understanding of what congruence means. Now, congruence means, in mathematics, it means the same. So here are some shapes, and I'd like you to take a minute to pause the video and answer the following question. Which shapes are congruent? All I need you to do, which shapes are congruent? Which shapes are the same? Pause the video and have a go. Okay, so some of you may have been able to do that, but for others, it might be a bit more difficult. So I'll give you some information. Here are some lengths to help you. So once again, same question. Which shapes are congruent? Now let's have a look. So which shapes are congruent? Well, these two parallelograms are congruent, and we know that because the sides have not changed. The only thing that's changed between this parallelogram and this parallelogram is the orientation of that shape. That means they are congruent. Let's have a look at another pair of congruent shapes. These two rectangles are congruent. Once again, the only thing that's changed is the orientation of the shape, which way up the shape is. Not the length of the sides, the only thing that's changed is the orientation. Once again, these two triangles are the same. The only thing that's changed is the orientation, leaving us with these two shapes. Now, although this length and this length are both 7, this length is 2, this length is 2 and this length is 4. So they are no longer congruent. So now that we understand what congruence is, we'll look at mathematically similar. So what does it mean to be mathematically similar? So mathematically similar shapes are when one is an enlargement of the other. And it doesn't matter which way around it is, as long as one is an enlargement of the other, those shapes are similar. So let's have a look at this in practice. So this is a wonderful slide that I've taken from Don Stewart. I think it was really useful. So here is a picture of a cow. And I'm going to try and make it twice as big. So here we go. Here I've had a go at making it twice as big. This is where you would pause the video. And have I done this correctly? Now, if you said no, you are correct. I have not done this correctly. As we can see, these two pictures, are not similar at all. This is a stretched cow and this is just a regular cow. Right, we'll try again. I'll try and make it twice as big. Pause the video. What mistake have I made this time? Yeah, once again, I've only stretched it in one direction. And they're not similar. You can look at them and say they're not similar. This is a very long cow and this one looks in proportion. So to do it properly, I need to ensure that both directions, both sides have been doubled. That way I get a picture, in this case, that is exactly the same as the other one, just slightly bigger. Bonus points for anyone that notices something cool about the cows. Right, moving forward. Here's a picture of a square. I'm telling you it's a square, you're just going to have to take my word for it. And I'm going to increase it by a scale factor of 2. That means I'm going to make it twice as big. I'm going to increase it to make it twice as big. Now, if I make only one side twice as big, it turns into a rectangle. So I don't want to do that. I need to make sure I make both sides twice as big. So I end up with a square that's twice as big. Now, that might be hard to notice, so I'll do it in a different way. So we know this length here is 4 centimeters, and this length here is 4 centimeters, making this a little square. And we're going to increase it by a scale factor of 2. So then I end up with a bigger square where the two sides are 8 centimeters. As I can see, I've multiplied both sides by 2. Now here's a question I'd like you to answer. Has the following shape been enlarged by a scale factor of 2? So here is the shape. Has it been enlarged by a scale factor of 2? Give you a minute, pause the video, have a think. If you said yes, you are correct because this length is 5 centimeters and this length is 15 centimeters. So I've multiplied by 3. This length is 3 centimeters and this length is 9 centimeters. So I've multiplied by 3. So I've multiplied both directions, both sides by 3. So this is an enlargement. So now we're going to play a game called Is It Similar? That's what we're going to play. It's called Is It Similar? So here is what it looks like. There are two rectangles. Are those two rectangles similar? Give you a second to pause the video and have a guess. If you said they are similar, you are correct. They are definitely similar. If you have a look, this is twice as big as 10 is twice as big as 5, and 6 is twice as big as 3. So one is an enlargement of the other, therefore they are similar. Another way you could look at it is 5 is half of 10 and 3 is half of 6. There is a scale factor between them, the scale factor being 2 or a half, depending on which way you're looking at it, and it's very clear that they are similar. Have I got these two? Are they mathematically similar? Well, yes, they are. They are mathematically similar because there is a scale factor between them. The scale factor being, in this case, 4/5 or 5/4, if you want to have a look. So, for example, this number is 7 times 10, and this number is 8 times 10. This number is 10 times 4, and this number is 8 times 4. So you can see that the scale factor is similar. It's 4/5 the scale factor is. That's what the scale factor is. The scale factor does not need to be a whole number. If we were going the other way, it would be 5/4. It would be 5/4 the size. We've increased it by a quarter. Right, let's have a look at this one. Is it similar? Pause the video, have a think. So now this one I've tried to catch you out. This one is not similar. Although the numbers look like they've been increased by 10, we need to make sure we look at the units of measure. So this is in meters and this is in meters. This is in meters, so I've multiplied it by 10, but this is in centimeters. So because there's a change in the unit of measure, all of a sudden, this hasn't been multiplied by 10. It's actually been divided by 10. So these two shapes would not be similar at all. Right, have a look at this one. Okay, and they are similar. Because if we were to change everything to a different unit of measure or the same unit of measure, we would notice that this one is an enlargement of this one. They are very similar. They are definitely mathematically similar. The key thing to take away from this example is that we need to ensure to be able to correctly identify if they're similar or not, that the units of measure are the same for all of the sides. Right, and here's our last one. Right. Now this one is slightly different because it's a triangle, and before we've only been looking at two sides. Here we need to look at all three sides. So we can have a look. 11 to 33 is timesing by 3, so we're okay. 11 to 33 is also timesing by 3, so far we think the scale factor is 3. 14 times 3 is, not 28. So this one would not be similar. It's really important that we make sure we consider all three sides in a triangle, not just two like we would in a rectangle or a square. Now here's an activity for you to do. Once again, the numbers have been taken from Don Stewart. I made a slightly adapted version of this. If you want to have a go at what version Don Stewart's done, you can go online, just Google it and you'll find it. What I'd like you to do is match up the similar triangles. That's all you have to do. And once you've matched them up, tell me what the scale factors are. I won't be checking to see what the scale factors are. If you want to do that in your own time, feel free. But I will just be checking if you can match up the similar triangles. So the blue ones will match to the white ones. The blue ones don't match to each other. The blue ones will always match to white ones. Okay. Have a go. Pause the video. Give yourself about 10-15 minutes. Come back and we'll check the answers. Okay, so here are the answers. N matched to B, D matched to K, M matched to C and I. So C matched to I and M if you want to think about it like that. E matched to P, F matched to J, A matched to G, and L. Now hopefully that's giving you a rough idea of what mathematically similar is. The best thing now is to go on and do some practice. The best places to practice, as I say, are Corbett Maths and Dr. Frost. Dr. Frost is a fantastic resource. Once again, I am in no way affiliated with them. I just really use their resources a lot and I think they are fantastic. I think it's a great place for you to go and practice, so go on and do that. Hopefully this has helped you. If you do get stuck or confused, feel free to come back to this video and hopefully it will help you moving forward. With that being said, go off and do some maths, go be productive and have a wonderful day.